Rồi, các bạn xem được chưa nhỉ?
Rồi ạ.
Ok. Kỳ này chúng ta sẽ làm việc với nhau trong cái môn gọi là thiết kế hệ thống điều khiển nhúng. Cái môn học này của chúng ta nó sẽ chia thành 2 buổi, đúng không? Một buổi là chiều thứ 3 và một buổi là chiều thứ mấy nữa nhỉ?
Thứ 6 ạ.
Chiều thứ 3 và chiều thứ 6. Tôi thì không thích một tí nào cái việc nó chia thành 2 nửa, 2 tiết một thế đâu, nhưng mà không có cách nào khác thì đành chịu thôi. Theo cái quy định của trường đó, chương trình đào tạo của các em thì trong cái môn học này của chúng ta trên khi mà nói chuyện trong lớp thì chúng ta trên bài giảng chúng ta sẽ sử dụng tiếng Anh. Cho nên bây giờ ta sẽ chuyển sang ta sử dụng tiếng Anh cho cái bài giảng của mình. Các bạn đồng ý chưa nhỉ? Ok.
Yes, teacher.
Okay, so I want to ask you about your study now. Which subject related to control engineering that you have studied in from your program? For example, did you study theory of linear control?
Yes.
Digital control?
Yes.
Digital control. Who taught you digital control?
We are learning it in this semester.
This semester?
Yeah, for the digital control design.
Digital control design.
Digital control system.
Digital control system, yes. But who will teach you this year?
Miss Nga. Miss Nga.
Vũ Thúy Nga, okay. Because I don't see it here. Wait a moment. Okay. So in your program, you have study about analog circuit design, right?
Yes.
Digital circuit design.
Yes, teacher.
Yeah. Okay. Then you have learned about the microcontroller.
Yes.
When did you study microcontroller?
We learned it in the last semester.
Last semester, okay. And you have also studied about the programming, right? Language.
Yes.
Before you study embedded, microcontroller, right?
Yes.
Okay, so good. That means you all have enough requirement in order to take the course. Because in this course we will use the knowledge from other courses, mainly from microcontroller, digital and analog circuit design. We will not repeat the knowledge from this subject, but we just use the knowledge from the other subject. Okay. And here in the slide, my slide, you see the name of the course and my name, my department, and as well as my email address. I also create a Teams group for this course, this class. So if you want to exchange information with me related to the subject, you can post in the chat in the team group. Okay. And all the slides from of the course will be posted on the. I will upload it in the file session in the Teams. Okay.
Yes, teacher.
Good. And now we move on to the outline of the course. Okay. So today we first we will talk about the motivation for the course, some main characteristic of embedded control system, and I think it will be and some design challenges during the designing a embedded control system. Okay. Mainly my motivation or my purpose for today is to make you to understand about what we will do in the semester, in this semester, in this with this subject, which system we will design in during this semester. Okay. This subject is have two parts. One is the course, and the other is the course project. You know, that's right. That means we have a project along with the course. You know, that's right.
So, sorry, teachers. So, do we have to take an examination for the final test, or we just have to do the projects?
Sure. You will have a project for the course, and then at the end of the semester, when you hand out the report for the project, I will take the score for the project as the midterm exam, and the final exam will be oral exam. Okay.
So the project is only for the middle exam.
It's not only for the middle exam, because the oral exam at the end of the semester is also related to the project, mainly related to the project. Okay. We will in the oral exam, we will discuss about the project, mainly about the project. Okay.
Yes.
Good. Now we move to, here is some reference that you can read with the course. Okay. And I will move to the next part, is which is the motivation for the course. You will see there's a sentence here. The future is embedded, and the embedded is the future. This sentence, I actually prepared this slide around 10 years ago. Okay, and at that time, this sentence was already correct, and it is still correct until today. Okay, so and the embedded system around us is the more and more expand. Okay, expand. Nowadays you will see the embedded system everywhere, in the daily life as well as in the industry. Okay, as well as the industry. So the first question now you should make for me to you should make the question now is the what are the embedded systems? Okay, so we move to the definition of the embedded system. So first of all, embedded systems are information processing systems. And the second, but if you just stop here, embedded system are information processing system, you will think of general purpose information processing system. But the embedded system is the information processing system which is embedded or integrated into a larger product or integrated into another system. Okay, and mainly when it is integrated into another system, mainly for the purpose of as the controller for the system. Okay, so first it is information processing system. Second, this is used as the dedicated controller for the other system, such as machine, in industry, or anything, as a lot of things in the commercial, in the daily life, such as vacuum robot, or a washing machine, or whatever in your house. Okay, because it is dedicated to what and it is designed just only for one purpose. It is for control the this system. Okay, so because it is dedicated for one certain application, that so normally the embedded system also have dedicated user interface. That means it's not normally it will not have a general purpose user interface such as screen, monitor, or keyboard, or normal, which is very normal for general purpose embedded system, right? Computing information processing system, normal. Okay, so when you think about the computing system or information processing system, most of you will think of device such as PC or laptop or mainframe or servers. And nowadays we can count to this list something like a tablet or smartphone. They are all general purpose information processing system. Okay, but the information processing system, there are a lot of another types of computing system. They are part of almost everything that runs on electricity. Okay, in industry as well as in the commercial, as well in the user daily life. Nowadays, especially in the industry, it's very hard, or if not impossible, to find a control system that not runs on embedded system. Okay, you will see that there are a lot of control system out there, but it's very, very hard, or if not impossible, okay, to find a system but not run on an embedded system. That means the embedded system now is everywhere. Okay, everywhere. Some embedded system is very simple. Okay, some embedded system is very simple, such as a digital transducer for sensor, for example. Okay, but some other embedded system is very, very complex, such as a PLC, for example. You know PLC? What is PLC?
Programmable logic controller.
And can you count or name some of them?
Siemens, Mitsubishi.
Mitsubishi, okay. And you know that if this PLC is just a embedded system that was designed for the other people or for the other engineer to use it in variety kind of application, you know, for general purpose PLC. It's just a embedded controller for general purpose system. That means you can use PLC as the controller for many systems, right? That means that the designer, that means, so who designs the PLC? There must be someone to design the PLC, right? And when they design a PLC, how did they do that? Or how the structure, the PLC system have been structured? What kind of architecture the PLC system have? Okay, so in my opinion, PLC is just a very complex embedded system, not as simple as, for example, the sensor transducer as we mentioned before, but it's much more complex. But in general, PLC is still a embedded system, not so different. Okay, because it's a PLC is for sure is a information processing system, right? And is normally is used in as a controller for other machine or other system, not standalone, not for general purpose. Okay, general purpose information processing system is mainly takes the input, the information, process it, and and introduce the result for the user. That means for the people who use it. Okay, but the embedded system is is not for the people who use their information processing result, but the result is used for control the other system. Okay. And nowadays, yearly must be billions of units of embedded system produced every all over the global. Okay, and if you for example, here in a automobile, in a car, for example, transport vehicle, there are a lot of systems inside a car, and each system have its own controller. Okay, for example, you can count on, for example, the engine. Yes, engine. For example, engine controller. We call it ECU, engine control unit. Okay. If you use some kind of motorbike like with fuel injection device, then for sure you will have a ECU inside the motorbike. Okay, and the ECU is stand for engine control unit. In fact, it is a embedded system, use a information processing system inside it to control the fuel air ratio in the engine. Okay, and the other systems such as stability control system or the brake system or the other system for body electronics such as lighting, signal, and everything. Okay, and if you pay attention on the news now, you may know that at the moment, a lot of car makers, giant car makers such as Tesla or General Motors have to reduce or to cut off the manufacturing process because the lack of microcontroller. Okay, you may see that okay, the microcontroller is nothing related to a car maker. Okay, but in fact they have to reduce the production line because the lacking of microcontroller now. Okay, here if you do in R&D division here in Vietnam, for example, now if you have some design and you want to buy a microcontroller in order to make your design into the production, okay, it's very hard to buy a suitable microcontroller. For example, now it's mostly impossible to buy an SD microcontroller. Okay, do you know SD microcontroller? In the subject of microcontroller, what did you have studied? Can you some guy of you tell me about the outline of the microcontroller course that you have taken?
We learned about 51 microcontroller.
51. Okay, and what else?
We have studied about the architecture of the microprocessor, how to it communicate with the peripheral, the input and how to output, and how to program in ST51.
51. Okay. That means you have learned a very basic course of microcontroller. Okay, you know that nowadays there are a lot of different type of microcontroller out there, and if you want to work in this division of the industry, you will need to be familiar with a lot of other type of microcontroller, right? And but it's just a question to make sure that you know. For example, when I talk about the SD microcontroller, if you don't know, you should put a question. Okay, here in the class, you will not you must not listen until I stop speaking. You can interrupt me and make a question. Okay.
Yes.
Okay, so another example for the application of embedded system you can see in the aviation industry. Okay, aviation industry, or in the medical devices. Okay, medical devices, and here is a very funny. Just for fun, okay, example for embedded system using in daily life. Okay, and here is the main subject of our course. Okay, that means we mainly we will design embedded system for use in the industry. Okay, for example, a controller in the industry to control a liquid level of the tank, for example. Okay, or you can use the controller to control the flow of the output liquid in the pipe like this. Okay, it's a very simple example of how to design a embedded controller for different application in the industry. So through or the other application, for example, in the building management industry, building management systems. Okay, it's also you will find the exist of embedded system everywhere in a modern house nowadays. Okay, from the cooling system to lighting system, lighting, not lightning. Okay, I'm have a mistake here. Lighting, I write here lightning, and so on. Okay, but the main purpose or the main focus of the course will be focused on the industry application. Okay, and when you say about the device that used in the industry or in the application like medical or aviation or automobile industry, then the first characteristics that you have to take into account when you design the device is, what is it? What do you think? What do you think? So from now, you will, in general, when you design a embedded system, embedded control system, you will design a information processing system, right? And if we talk about designing an embedded information processing system, what characteristic or what requirement do you think about the requirement for the system? What kind of requirement here? How do you think? Yes.
I think it is the precisely and stable.
Precisely, and the stable.
Yeah.
Okay. But it's the you say that, okay. Yes, that's right. Okay. There are a lot of people think that when you design an embedded system or a computing system, the first requirement will be the power, the computing power of the system. But in fact, the industry application not require much or a lot of power, computing power. Okay. The main purpose or the first characteristic that you will require or will need your system have is the reliability. Okay. Embedded system must be dependable, because you know that your embedded system is not for general purpose. For example, for a tablet or for a general purpose computer, if it cannot display a web page on time, what happened? Or for example, your tablet is failed to start up, what happened? What is consequence of this failure? I may say nothing, not very serious, right? You may, for example, start it again or reset it or whatever. Okay. But it is because the tablet or your computer is a general computing system. The requirement is not very high. Okay. But if your device that you design is used as the controller for the system, for the whole system, for example, the controller for car, controller for plane, controller for process, industrial process, so it must be dependable. Okay, you cannot afford the price or the consequence of the failure in your system here. Okay, as an example, if you still, or some of you may know the things that happened a few years ago about 2018. It's a Boeing 737 Max. Do you know about the situation? 2018, two brand new Boeing 737 Max is fall from the sky. They was both brand new plane, passenger plane. Okay, and this accident killed almost 400 people, and all the production line of the Boeing 737 is stop, go stop until now. Okay, until now, the Boeing 737 still not be able to fly again, and thousands of people lost work. Okay, the economic loss is very, very high, and the more serious is the loss of people life. Okay, so these two planes are was very new, almost brand new, just few months of operation, and it was a failure in the control system, in the system which maintains the balance of the plane. Okay, so the pilot was do everything they can to keep the plane on the air, but the automatic system controls the plane to crash on the ground. So this is a very serious failure of the control system on the world. Okay, and this system is embedded system for sure. So that's why when we design an embedded system, depend on the first characteristics that we have to name, to pay attention is reliability. Okay, and of course the reliability is depend on the application of the system. For example, if you design a embedded control system for the machine or for a device that will use as a commercial device, such as oven, aircon, or fans, or ceiling fans, or lamp, for example, then your system is going to be categorized as the commercial device. Okay, but if you design a embedded system that used for a industrial machine, then your system should be categorized as industrial grade device. Okay, and if your system, of course, your system will be used in the car or in a transport vehicle, then your system should be categorized as automobile grade design. Okay, and when you design the system, you will have to decide that what kind of component inside it you will use. For example, you use the automobile grade components, or you use industry grade component, depend on the end application that your system will be used. Okay, so the reliability is must be taken into the consider when you design the system. Okay, we will come back to this reliability characteristic of embedded system later on, but the first thing that I have to focus you have to focus on is from the beginning of your design, you have to put this requirement on the first priority. Okay. The second characteristic that any embedded system should have is maintainability. Okay, that means the system. That means the system should may have a ability to work correctly after some time that the error occur. Okay. And the other, for example, availability or safety or security is the other requirement of the system. But for the first position is the reliability. Okay. The other characteristics, for example, efficiency or yeah, of course, when you design a system, you have to when your system is going to the production, you must cut as much as possible the cost for the system. Okay, when you want to cut the cost, you have to cut the R&D cost as well as the production cost. Okay, and of course, because your system, embedded system, will be integrated into another machine or another system, so the size or the size of the physical size of the system will be limited. And sometimes if your system is working on the battery power supply, then your energy consumption should be limited. Okay, but this requirement in fact is for this course is not very important now. Okay, but for this course I will focus you mainly on the dependable of the system. Okay, reliability of the system. Here is a block diagram or a diagram of a very typical embedded system. Okay, embedded system. As you know, as I said before, that the embedded system is integrated or embedded in another device, another system. So this another system, we call it physical environment. Okay, we call it physical environment. That means, so in order to work with a typical physical environment, the embedded system should be able to collect the information from the system, right? Here you can see that here is the physical environment, and the system, information processing system, is the core of the embedded system here. And the embedded system should be collect the information about the state of the physical environment through kind of sensor. Okay, different kind of sensor, and the information will go into the through the okay, signal processing, signal conditioning, or signal processing part of embedded system, and generate information to the or provide the information to the information processing. Okay, and all the information processing process will happen in the core of the system. For example, if you design some controller, okay, it will implement it, the controller will be implemented here. For example, in the cost of the digital controller, okay, you will design a controller for what kind, different kind of physical process. Okay, So the controller will be implemented here. Okay, is use information from the process. Okay, through the input of this embedded system. Okay, and then in the information processing system, you will design a algorithm which is related to other subjects such as digital control. Okay, and the result of the information processing will be used for first, the result will be used to make some adjustment or some change in the environment, physical environment. But of course, embedded system cannot directly change or make some change in the physical environment. But normally, the we will have some kind of device, we call it actuator here, in order to make the physical change into the physical environment. Okay, so the output or the result of the information processing here will be generated as some kind of signal, and the signal will be control or make the actuator to change the physical environment here, the input of the physical environment here. You see, so the other result of the information processing will be go to the display unit, or we can call it the user interface. Okay, not only the display, but in general we call it user interface. Or this user interface not only for the user as the human, as operators, but also for higher level of controller, for example, or other controller that work together with this control, this embedded system. For example, when your embedded system control a machine, and this machine is just a one portion of a production line. Okay, it's just a one part of the whole production line. Then, of course, the whole production line will have its own control system. For example, a POC system, for example. That means your controller for the physical environment here should receive the order and report the result to the higher level controller. Okay, and this we call here all of this as the display. Okay, as a display. That's all. In more precisely, is the user interface. Okay. At this point, I will to more clearly understand about this architecture. Okay, I will give you some example from different manufacturer different system. Okay, here in this embedded system here, you will see a loop, information loop here from physical environment. Okay, from physical environment to yeah, you will see a information loop here, right? Okay, information will be collected from the physical environment at the input of the system, and then the information will be processed, and the result will go back to the system through the actuator here. Here is the actuator. Okay, and the information about the system is collected through some kind of sensor here. Okay, sensor here. So if when we talk about design a embedded system, okay, when we talk about design embedded system, our mission is here. Okay, our mission is here. Our mission not include the sensor and not include the actuator. Okay, this is not for designing embedded system, because normally this sensor and actuator to design it or to use it is not on your hand. Okay, normally the engineer who designs the machine or designs the physical environment here will select or will choose the engineer who designs this device, this system will select or will choose the actuator and the sensor and the suitable sensor, suitable actuator for the system, for the whole system, not the controller design, embedded system design engineer. You, for example, if you are the engineer who designs this embedded controller, you will give some, you may have chance to give some suggestion for the engineers who design the physical environment or physical device here. Okay, of you can make some suggestion of using actuator and sensor, but the decision is belong to the engineer who designs the physical environment here. Okay, that means when you design a embedded system here, you have to design the input. Okay, you have to design the input of the embedded system. I circle in the purple here. Okay, and you have to design the output of your embedded system in order to comply with general or typical types of sensors here and general types of actuator here. Okay, because you don't know, generally you will not know which kind, what kind of actuator or what kind of sensor will be selected for the system. Okay, so if you design the embedded system in order to work with general purpose, with this system here, you have to design the input and the output of your system. Okay, in order to comply with the general or common use sensors and commonly used actuators. Okay, for example, here, if the actuator is the for example, pneumatic valve, control valve, then the control valve normally have its own controller, and the output here should be, for example, 4 to and the output here, for example, in general, 4 to 20 milliamp. Cannot write here. Okay. And the same for the input. The same for the input over the, here. That means you have the design the input in your embedded system in comply with the output of the sensor, of the common use sensor here. Okay, and you have to design the output of your system comply with the input of common actuator, which can be used for this physical environment. Okay, that means in general you have to define that your embedded system will be used for what kind of environment, and in this environment typically what kind of actuator they will use, what kind of sensor they will use. Okay, so the mission of designing embedded system is in the red circle here, but you have you should have the knowledge about common type of actuators and common type of sensor, which will be used for the physical environment here. Okay. For example, if you design a controller, embedded controller for a physical environment, here will be for example, industrial ovens. So the information here will be the temperature of the ovens. Okay, then you should know that what kind of commonly used sensor for temperature. Okay, you can see that, okay, the sensor the temperature in the industry, normally they will use, for example, thermocouple or resistant, okay, or thermal resistant. Okay, then you will have to design your input here that can be accept the output of commonly used thermocouple and commonly used thermal resistor. Okay, because you will not know that the engineer who designs the oven will use the sensor. The sensor they will use here is the thermocouple or thermal resistor. Okay, thermal resistor. So in order to make sure that your system will be able to, or will be ready for use with this oven, you have to design the input here which can accept both signal from both type of sensor. Okay, and the same for the output here. The same for the output here. For example, the oven, I have said it here. The oven will maybe use gas as a fuel, okay, or use the steam as the heat source or whatever. Okay, so the commonly used actuator for those applications, what are they? Okay, or is used electrical heating device as the output, as the heating source. Then the output here should be, okay, for example, should be the analog output signal from 0 to 10 volts, for example, or 4 to 20 milliamps, for example. Then if you say that, okay, I will work with some typical types of the actuator for the heating ovens, then your signal here should be comply with this kind of commonly used type actuator. Okay, any questions here? Any questions here, guys?
No, teacher.
Yeah.
Okay, so I will show you now some general. Here you see that a embedded control system will have three main parts. Okay, actually four main parts. Okay, one, the core is the
Transducer, process information, and display output.
okay, information process. The second will be input. The third will be output. Okay, sorry, the third. Okay, the third will be output here, and the fourth is the interface. Okay, user interface here. So I will give you some example of architecture of different kind of embedded system that is recommended by some different semiconductor manufacturers. Okay, here you can see, for example, now I will open the web page, their web page. Sorry, it's not their web page, it is for example here. Okay, I will this is Texas Instrument, which is very famous semiconductor production manufacturer. Okay, and I will go to the different kind of application here. You will see that this manufacturer produce or their product can support a lot of application. I will focus on the industrial application, and I will deeply focus on the factory automation and control here. You see, and in the factory automation and control, there are a lot of smaller applications, such as, for example, programmable logic controller. If you want to design a programmable logic controller, is it possible? Yes, it's possible. Nothing is impossible here. Okay, we will not design a rocket science rocket controller. We just design some very normal controller. Okay, so programmable controller. If we want to design it, okay, yes. And industrial robot, if we want to design it, yes. Transmitter for the transmitter and actuator, if we want to design controller for it, because the actuator is the not only not always a simple device. Sometimes the actuator itself a very complex system. Okay, and this complex system, okay, in turn will have its own controller. For example, here I will show you. For example, here actuator here. See, you can see. Okay, here is the architecture of the. Of course, it is just a suggestion, but you will see very clear here. The main, the first part, the main information processing unit here. You see, and on the side, on the right hand side, you will see the the microcontrollers, which can be, or that's the TI suppose that it will best suit for this purpose. Okay, of course you can use other type of microcontroller. It's not very important. Okay, but in general, you see the overview of the architecture of the embedded system, which is used to control a actuator. Okay, for example, here you have the first, you have the center part is the information processing. You will see the input of the system, okay, which receives the signal from the actuator. In this application, the actuator itself is the physical environment that your embedded system have to work with. Okay, so here is the input, and here the output. You see, output, and at the in the bottom here you will see user interface. Okay, user interface. Here other user interface, and here is the interface for higher control system, higher level control system, for example. See, so the whole here is service or user interface. You can see here, right? Can you see the screen clearly? Okay. So on the upper part here, we can see it's a very important part of embedded. Any embedded system is the power system, power supply system. Yeah, see. But in general, you will see first the architecture of embedded system: CPU, input, output, interface. Okay, that was for actuator. Embedded system for as the controller for actuator, different general type or different kind of actuator in industry. Okay, And this architecture can be used, for example, to control the control valve, okay, or the motors, or whatever actuator. A lot of kind of actuator in the industry, okay. And I will take another application such as industrial. Here, for example, mobile robot. Okay, mobile robot. How to pronounce correctly? Mobile robot or mobile robot?
I think it's a mobile robot.
Okay. And here we are Vietnamese league. So sometimes I will pronounce not very precisely, and sometimes my grammar in the sentences also wrong. So just remind me if you recognize the mistake, or just okay, let it go, ignore it. The most important is you can understand the information. Okay.
Yes.
Okay, here you can see that, for example, in a mobile robot that used in the industry, and I will open a architecture suggestion, suggested architecture of the controller for mobile robot. You can see here, okay, digital processing. That means the core of the embedded system. Of course, connected to this core or supported to this core, you will have to have a memory, clock, or sometimes you have a wireless interface, for example. But the most important here is just the, you see, it's just a system controller for mobile robot. Okay. For mobile robots, that means here you will not see directly the input and output of the embedded system. Here you just see the here the processing unit, and then the interface here, and the other the rest of the system. So that means the input and output will be here. Okay, all the input of the output will be designed as the design of mobile robot. Normally they use as we call it modular architecture. That means we have the control module and input and output module. Okay, here you will see the input and output here. Here we have they name it as analog front end. That means here the real signal, the input and output signal will be connected to the environment, that is the robot. Okay, and then the information will be processing here in the information processing of the I/O model. Okay, and then through this interface, it will the result or the information will be generated, will be sent or will be exchanged with the, where is it, the controller, the main controller here. You see, so this main controller and the I/O module will combination of this main controller and the I/O module will form the complete embedded system. Okay, which is have everything: input, output, main controller, and user interface. You see here. Okay, you see here, user interface. This is the architecture for design an embedded control system for mobile robot. And other type, for example, here you will see the same for industrial robot here. you will see you will have a robot CPU board, that means the controller, I/O module, okay, as the input and output, and communication module as user interface. You see, yeah, CPU the same as the mobile robot CPU, okay, architecture, main processor, some kind of interface, some kind of user interface, okay, and the I/O, where is this? Yeah. I/O module. You have analog front end in order to work with the signal from process from the environment, okay, and then the main controller to processing, okay, the signal here, and then the communication line to exchange the information with the main controller module, okay, and the same architecture you will see, for example, here in the programmable logic controller. See, you have a CPU and you have different kind of input and output module. Okay, the input and output module will process the signal from the environment. Okay, and the result of the collected signal will be transferred to the CPU. For example, I will open the digital input module here. This, yeah. So the architecture here, we will have the signal input, okay, here, and then the main processing here is being collected the input, the status of the input from the environment here, okay, and the result will generate, will exchange with the CPU module over some kind of interface here. See, so if you see the whole system here of the programmable logic controller of the PLC, you will see that you have the CPU, that means the number one in our diagram, and the input, including analog and digital input, as the number two in our diagram, and you have the output, analog and digital output, as the number three in our diagram, and some kind of communication module as the number four in our diagram. See, so the whole system, the whole architecture will still have the four main parts: processor, input, output, and interface. Okay, and if you have time, you can you can read from a lot of other types of the embedded system here in this web page of the TI. And if you want, I will give you some example. For example, from another Infineon. For example, here. And you will see that the embedded system that's suggested by Infineon have the same architecture as the, for example, here. For example, here, industrial drives. That means the embedded system for motors, okay, for motors. You will see where it is. It's not only the controller, it's also the here, for example, I will take another example. Micro PLC, in order to not as the modular PLC. You can see the whole in the one diagram. You see here, controller. So in this diagram, when you put your pointer in the controller, it will suggest you what kind of microcontroller you should use. Of course, you can choose another microcontroller from another manufacturer. It's not a problem. Okay. And you can have I/O. That means the input and the output. You will have some kind of interface here, such as I/O link or whatever here. Okay, some kind of input and output transceiver. Transceiver for what? Transceiver, different kind of transceiver for information for industry, for industrial few bus here. Transceiver for I/O link or automobile CAN. So the architecture is still the same, right? Architecture is still the same. And if you consider another, for example, what service robot, for example, you can see here. Okay, it's still a embedded controller. Okay, embedded controller which contain one microcontroller here. Okay, main controller here, and the other will be you will see at the output there are some kind of actuator controller here. Okay, on the side output you will see there are many kind of motors as the actuator controller here. Actuator itself has this its own embedded controller. Here you see inside the actuator controller here you can see its own embedded controller here. And the robot controller will have some input. For example, you can see here industry I/O as the input and outputs. Okay, that means the number 2 and number 3 in our diagram. And you can see here a part of connectivity, which is number 4. Here, connectivity and interface here is is the number 4 in our diagram. You see, yeah. So this is a general or general architecture of a robot in industry from another semiconductor manufacturer. Okay, semiconductor manufacturer. When you design nowadays when you design a embedded system, is it not? I will not suggest you to build everything from the ground. That means you will use a discrete component to design the system. No, I will not support this idea. Okay. Nowadays, if you design a embedded controller for any system, so the first thing you have to take into account is to verify or to consider some suggestion from manufacturers all over, for example, from TI, from Infineon, from ST, for example. Okay, they are a lot. They are very, very common semiconductor manufacturers that you, and they, of course, in their suggestion, they will use their product, but we can learn from their architecture. Okay. Here, for example, other type industry, factory information, factory industry robots, for example, here. They don't suggest, don't have any. SD don't have any suggestion. Here, for example, a suggestion of SD for if you want to design some kind of PLC. Okay, you will have a control unit. That means the main control unit. You will have connectivity. That means kind of interface. Okay, you will have a kind of input and output, which is not in this diagram, but related to another diagram, such as input and output modules. See, here you will have a input and the output part of the input and output modules, and then connected to the main processor. Here is a MCU or the processing unit for the input and output modules, and then it's connected to the main controller through the interface, internal interface of the control of the PLC. You see? Yeah. So in general, you will say I will say that okay, there are many suggestions from different manufacturer about the architecture of commonly used embedded controller system, but they are very the architecture are the same as we have on our diagram here. See, information processing, input, output, interface. So the whole semester here of our in this subject will focus on these 4 parts. Okay, these 4 parts. Of course, another very important part of the embedded system is because you have a information processing here. That means you will have to design a. This is the whole system is one information processing system. So there are some kind of software running inside the information processing unit here. Okay, so the other very important part of our course will be you will learn how to design a reliable software for embedded system. Okay, so there are 2 main parts of our course. One, design a reliable hardware for embedded system, industry grade embedded system. Okay, and the second, how to design a reliable software for our embedded system. Any questions here?
Yes.
Yeah. So I suppose that you all clear about the purpose or the and the main okay contents of this course. Okay.
Teachers, there's a question in the comment box. Can you
No, don't need to read the comment box. Just discuss about it here. Okay. Turn on the micro, the mic, and say the questions. Okay. What is your questions?
He asked that the embedded system usually based on either microprocessor or microcontroller. Are there any difference about them, and which is more commonly used in the Vietnamese industrial?
It's very good questions. Okay, because it is information processing systems. That means you will have some kind of information processing device here inside it. I will come back to this example. Okay, this example. For example, robot CPU work here. For example, you will see as the processing unit here. You will see they listed. Here is the ARM, ASIC, x86 or FPGA. These are general type of different kind of information processing technologies, in which the ARM and the x86 is the microcontroller. Okay, the rest, the other two, ASIC and FPGA, are kind of programmable logic devices. Okay, logic device. So in general, you can use any kind of information processing here, FPGA, ASIC, or microcontroller, or microprocessor here. Okay. For example, here in the list on the side, you can see there are ARM-based processors, or microcontroller, or ARM-based microcontrollers, or digital processor. Okay, so we have in the list here we have both microcontroller and microprocessors. Okay, and if you in your questions have another a second question in is the difference between microcontroller and microprocessor, right?
Yes.
Oh, yeah, the microcontroller is the microprocessor with some peripheral, integrated peripheral, ready for use in the as a controller as a controller in the system. So they call it microcontroller. Okay, in fact, it is the microprocessor with some integrated peripheral, such as input, output, communication device, and so on. Okay, so basically there are no difference between the microprocessor and microcontroller. Just it's the only difference is when you use in your design. The microcontroller is more compact. Okay, because you don't have to design a separated peripheral for it. Okay, but in general, the microprocessor will have the stronger computing power than the microprocessor have stronger computing power than the microcontroller. Yes. Okay.
Thank you.
Any questions? Okay, if you don't have any questions, any more questions, so we will. I will stop the lesson for today now, and we will. Sorry.
Em thầy, em có một câu hỏi ngoài lề bài học một tí ạ.
Okay.
Thầy là em là học sinh đồ án 1 của thầy kỳ trước, thì giờ bọn em vẫn chưa hoàn thành, thì kỳ này bọn em có thể tiếp tục làm được không ạ?
Không cả. Bởi vì kỳ trước chúng ta bị cái vướng cái vụ Covid nên chúng ta không lên làm thực hành các thứ được, đúng không?
Vâng.
Thì kỳ này hôm trước tôi cũng đã nhắn với các em rồi là các em cứ lên Kỳ này cứ lên gặp tôi để tiến hành cái phần thực hành thôi, chả sao cả.
Vâng, tức là cái điểm đoán 1 thì nó vẫn là chưa hoàn thành chứ không phải là
Không, điểm đoán 1 thì hoàn thành rồi, bởi vì là bắt buộc chúng ta phải lấy cái báo cáo gọi là cái phần tìm hiểu của các em mới làm cái điểm thôi. Nhưng cái phần thực ra cái đồ án 1, cái mục tiêu của nó là nhấn mạnh vào cái phần thực hành cho các em ấy, chứ còn cái phần mà tìm hiểu đấy thì nó cũng vừa phải thôi. Thế nhưng mà vì cái tình huống là cái Covid cho nên là bắt buộc ta phải lấy cái phần tìm hiểu đấy làm điểm đoán, em hiểu không?
Vâng.
Thế còn để gọi là trả nốt cho các em cái phần thực hành đấy thì các em cứ lên gặp tôi thôi.
Vâng.
Bởi vì là đồ án này không phải là các bạn phải nhớ là các loại đồ án với lại bài tập ấy thì không phải là nghĩa vụ các em phải làm, mà đấy là quyền lợi của các em nhá.
Vâng.
Đó. Đấy, các bạn phải hiểu đấy là quyền lợi của mình đấy, mình được làm đấy. Thế mà được làm mà chưa đủ thì ông phải đòi nốt, không hiểu không?
Vâng.
Đấy, quan điểm nó phải như thế thì nó mới đúng nhá. Ok. Rồi, nếu các bạn không có câu hỏi gì nữa thì chúng ta sẽ dừng cái buổi hôm nay ở đây. Rồi, chào các bạn nhé.
Em chào thầy ạ.
Ừ.